Here we go. Hi, welcome to this second Open Security Summit session around the Glamorous Toolkit, namely around the moldable development practices that it enables. And this session is going to be, the second section is going to be a lot more sort of Q&A. So I have a whole bunch of questions, a whole bunch of areas that, I want to sort of ask and pick Tudor's brain on this, since he's, the brainchild, I believe, on this. Actually, why don't we just start from there? So, maybe just a quick introduction. So, just a quick introduction from you, Tudor, and then we'll take it from there.
Oh, yeah. Hi, thanks for having me. I'm Tudor Girba. I'm the CEO of Think. At Think, we are particularly focused on, or our mission is to make the inside of software systems explainable. We're working on that so Think exists now since almost 6 years, but this effort actually is longer. It's about 12 years now, and it has always been a group effort. So the Glamorous Toolkit is built by a team, and it's the current Glamorous Toolkit is a second generation of this technology. The first one was created also as an open source project, but as just an independent team, and that one was actually integrated into Faro. Faro is a Smalltalk language, an open source language, and it helped us. It showed what moldable development is. The original idea of moldable development came about 12 years ago when I authored another method, which is called humane assessment. That's the precursor of moldable development. And it started from this idea that developers spend most of their time figuring the system out, right? And since then, I talked with several thousand developers, and I asked them, do you agree that you spend more than 50% of your time doing that, and that most of that time is actually just spent reading? And people say yes. And then I say, well, so when was the last time you talked about how you read code, or how you read the things necessary to understand what your system is doing? And it turns out it's not a subject of conversation, and that's like an odd thing to have, because having or spending the largest chunk of your budget on a single thing nobody talks about, it's just not the most ideal thing to do. And at the same time, we know that we don't have enough time. So, and every time you want to optimize a system, it's you're going to look for the largest chunk that has never been optimized, because that's what will probably give you you have the potential of an order of magnitude. And that's exactly what this is. It's like more than 50% of our job, and we're not talking about it. Right? We're talking about how we construct systems a lot. And if you look at the outcome of that, where are we now? We are at the place where we can churn systems faster and faster. Like we can create systems faster and faster. In fact, the body of software grows non-linearly or super linearly year over year, right? But at the same time, we are unable to recycle old systems. So this is what I call a software environmentalism crisis, because it's at a large scale. And what does it mean to recycle a system? To recycle something means to take it apart and refurbish it for new purposes. But before you can take something apart, you first have to understand the parts. And if the understanding of those parts, is based on our ability to read, then we have a big problem, because reading is capped at a constant speed. I mean, even if you read very fast, it's still going to be capped at a constant speed, and it cannot match an exponential curve.
The problem there is not read, right? Isn't the problem there actually modeling, right? Because even if you could read fast enough, like, for example, when you took those examples and you had the codes and you had the multiple things, once you brought it into a model, right? Once you brought it into a way to represent the data, your ability to consume what's there gets exponential, right? So, I would say that even if you could take the time to read, for example, code, right? If you can't understand what the code is doing, if you don't understand the implications of the code, right, then that's the big problem. So what I found is from a security point of view, I found that most security vulnerabilities are created by a lack of understanding of the side effects. Like very few developers, unless they want to do it on purpose, right, arrive one day to work and says, I'm going to write a great security vulnerability, right? They don't do that. What happens is a combination of things. Is using a framework that has a side effect you don't understand, is connecting a bunch of dots that you think, well, that's going to be okay, or thinking in the current design it's secure, not realizing that the next version of the design or the evolution of the design is going to create connections that is going to make that assumption, in a way, that part of the graph there that was okay in, for example, a particular graph, a particular code structure or ecosystem, right? And becomes a problem further on, right? Because I think what's interesting in security is security almost is a great canary in a coal mine, right? Security gives you almost a preview of what will happen if somebody almost starts to poke the system in almost like in non-functional ways, right? In ways that the system is not supposed to be used, but still supports, right?
Yeah. So you're right, right? So it is not understanding a system is not a reading problem, right? Or should not be seen as a reading problem. But it's fascinating to see.
Absolutely not. Can I just jump in there? I think it's really important, obviously, to be able to reason about the code. And I think I haven't done any serious software development for 10 years now, and I think we've got an evolution around software languages. We've moved to automated memory management. We've gone through encapsulation and object orientation. We've got functional languages where it's a lot easier to reason about a pure function. So I guess the question for you is with the moldable stuff you're looking at, where do you think language evolution should go? Because I think you're obviously trying to integrate with, I think there was some Node and some Python yesterday you were looking at, but if the language moves to sort of help you doing what you're doing, what sort of direction would that be moving in?
Look, there's no language today that will have any first-class entity about security, for example. So whatever the language, whatever people might think the language does, you're going to have a gazillion more languages implicitly built on top of it. Absolutely. So if you're not prepared to reason about those, you're going to be left exposed, basically, because your understanding will always be lacking. So, all these, there was, for a long time, right, there was this thesis like if only we have the perfectly, the perfect language that will express everything we want to express in the most purest of ways, we're gonna improve the situation. Now, so 10,000 more, 10,000 plus more languages later, the situation is not being improved. So could it be that that's not where we should necessarily look for? I'm not suggesting that we should not be looking for higher levels of abstractions. What I am saying is that reading or the figuring of the system out is orthogonal to the writing problem. And those two things should not be merged together because they have different needs. So for example, if you look at, when people say, well, visual programming languages for end users, that they are a good idea, and they are a good idea. They are a very interesting idea. But they always tie a single representation to whatever is being expressed. That is what we are challenging. What we are saying is that there is no single representation. There's no form. There's no single form to read anything when it comes to software. Like, however we wrote it, it's almost irrelevant to how we're going to read it.
So this is where, and actually, just for context, Martin, are you aware of worldly maps? Do you know the concepts? Cool. So when I think about this, I basically, in my head, I view a map problem, right? And one of the things that, again, Simon talks a lot, which is there is not one solution, right? There's not one way of looking at the problem. You almost need to have situational awareness, understanding what is the context that you're in, and then knowing what you need to be looking at, right? So the reality is, and the reason it's quite funny, because moldable, in a way, moldable development, the way you talk about, and I want to expand a bit on that one, for me felt really natural, because that's how I tend to think about things. So your idea of and maybe correct me if I'm wrong, but your idea of moldable development is to say, when I hit a point and I ask a number of questions, or I want to see certain things, and I don't have an easy way to see it, I need to mold it, right? I need to build what you call the mold, right? Or a tool, go on that tangent so that you can come back to it and going, oh, now I can see, right? Now I get that bit. And then if you do that in an iterative way, you get better and better, you get faster and faster and faster with your development and your understanding of it, right? Is that a good definition of the moldable?
Absolutely. Yeah, moldable. That's the whole point. The idea is every time I have a problem, every single time, and I'm not like, this thing is so addictive. And we smile all the time. I mean, we love working with legacy systems, for example. That's one of the things we do. So maybe you were talking about wordly maps. So let's see how that would look like.
Yeah, and just a quick one. And on that one, it means that if you now imagine, for example, the level of granularity that you can see on a map, you could see that in one level, you actually want to read source codes, right? But on the other level, you actually almost want to read visual representations of what's been created, right?
Yeah. So if you think about it like this, so if we have here developers or business and they have some sort of a challenge about the system, and the challenge is always specific. There's a specific problem to it. And what people want to do is they want to understand enough to make a decision. We call this one assessment. Now, the way typically this happens is by people they build manual views, so that maybe drawings, right? So for example, we ask people, do you have a picture about your system? Right? It's like every time we go into a legacy system, people say, well, we have a problem. So, well, do you have a picture about the system? And they say yes. And then we say, well, can you bet your salary that the picture is real?
Yeah, of course. No.
And people say no, right? And now think about this. Why do we use that picture? We want to use that picture because we want to make a better decision, a faster decision. Yeah. But what if that picture, if you don't know whether this is real or not, then you're in a fake news environment. You should never, it's a belief, basically. Every time somebody draws a picture by hand, like this one, it's a belief. And usually the way this picture is being drawn is based on some sort of a manual inspection. And this inspection is manual because of the rigid tools. So now we have tools that are commodities or almost commodities. They're products, right? Like an IDE or so. But what you really want, you do not want this one to ever be manual. So what you want is you want this view to actually be a commodity here. You want this view to be a generated view. And so let's make this one this is what we do. So what we want is really this. So we want assessment to always be based on generated views. Now the question is, we've had tools that produce views about systems for a long time. And I come from research, and I wrote papers, a significant amount of papers about, generating views on a one click of a button, and they never work in practice. And that's what I found out. Like said, okay, we said, well, after having built a number of these tools, and then we said, well, okay, let's see which one would affect people in reality. And what it turns out is that I said, well, I don't know exactly which of these tools we should start from, but what I will do is I will do some consulting projects to figure out, which of them is effective. And I started the first one and the second one and the third one. And then I realized that the only thing that was recurrent and then I could reuse was this thing that I always had to tweak I always had to do some specific coding here. That these views, it was great to generate these views, but they always had to be based on some sort of specific coding. So I wanted to do, to get those from here to there, right? So that's what we want the evolution to be. And we want the evolution to go from here to here as well. And right, so something like this, and maybe make it larger. But then the question was, how do you do it, right? So it was very important to always relate whatever automated view I create to the specific context of the problem. That was absolutely imperative. Like, so this part over here was really, really important, because without it, it just never works. This problem, this specific coding has to be related to this specific problem, and then generate the views. And then, so the only way to make this one now practical is to maybe, to productize this one over here. So to say that we introduce these moldable tools here. So these moldable tools are an evolution over the rigid tools, but like this, maybe we say arrowhead as well. And this is what enables and after makes this coding, specific coding, actually be practical enough. So to actually be, usable in practice, because the core idea of a moldable environment is to make this coding really, really small, so that we can create the views that are necessary for driving this assessment at a very low cost. And so that's basically the essence of moldable development. And this is how we see. We see this one as a missing or as a necessary skill that should complement the existing kinds of skills that exist usually in a team. And that we also see it as introducing a new kind of a feedback loop in software development that simply doesn't exist.
Yeah, one of the problems that you're trying to address is, which is, I would add to that shocking analysis of, we spend developers spend a lot of time reading, I still develop a bit, spend a lot of time reading code, but we don't spend a lot of time making that reading or that understanding more effective, right? I think one of the things that's very, I think, bad practice is that we don't spend enough time trying to make the development more productive, the development environment more productive, right? And even the development itself more productive, which is what you are hinting here, right? So as we create things, and actually, do you have any data on this, right? Like what's a good balance? Is it 20%? Is it 30%? Is it 50% of the resources should be, focused on creating those generated views, right? Because the problem is that generated views that you have there, they will have a lot of times to be customized, right? To a particular application, to a particular workflow, to a particular use case that we have. And they can be very complicated to develop, right? The difference is that
they don't have to be. Well, they don't have. That's the interesting thing.
No, fair enough. Okay, but they require engineering, right? Okay, we can make the process very easy because we could but yes, you can build a framework to build the framework, right? Which is great, which is the way you scale. But you still, put it right, they would always going to be more complicated than the use of the view, right? So the point again of generating your views is that when I want to use them, they're very simple to use, right? I can make my assessment, or you could change that assessment to development, right? Or creation almost, right? Because your views allows you to make good decisions, right? Your views allows you to understand or know what to connect, how to do things, what's going on. It's almost about the feedback loop, right? The views give you faster and faster feedback loop. The more feedback loops you have, the more productive you are. The more, creation, the more the kind of connection you have that. And actually, the question I had for you is, have you seen Brett Victor's Inventing on Principle? Surely you have.
Sure.
Have you seen that one?
Yeah.
Because this is very related to that whole, having a direct connection between the creators and what they create, right? Is the idea that your views allows me that once I move something, I get very, very quick feedback, right, on that. But again, from your experience where you've seen it work successfully, how much of the dev team is spent on generating those views versus the dev team or the team creating things, actually doing the assessment and the work and the actual, almost developing something that is more visible from, the end result, the end consumer.
Yeah. So that's a very interesting question. So first, just a few things. Should tools be expensive? The tools that we have today are probably an order of magnitude more expensive than they need to be. And that's what we're showing in Glamorous Toolkit. Like just last time, I showed you maybe 2 or 3 different kinds of tools that otherwise people would consider as being full-fledged tools. And then for us, it's just a combination of a few lines of code that will bring you those. And we have literally hundreds of those kinds of cases already. So, I mean, just with Glamorous Toolkit, we have more than 1,000 plugins, right? Just coming out of the box. Now think about,
the real
for example,
cost is the human cost, right? Don't underestimate, like the real cost in a lot of things is actually the person, right? It's actually the person who's going to put context.
Okay, so
that has a real cost too, right?
Now let's put this also in context. So this work is actually based on 12 years of fundamental research and validation in industrial case studies. We're not, this is not just something, it's not just an opinion. We also got interesting or reasonable recognition for this from an academic perspective. But what I'm saying is we had similar conversations. I remember when testing became a subject, right? And people were saying, so how much of testing is too much, right? Or you know, how many people should be doing testing, given that we had at that time there were, or even now sometimes, you'll have specific people that are only doing testing, right? And then that testing was just measured in clicks. So if you think about, you know, this 50% of more of the time spent on reading, that's budget that already exists. Now, I am yet to find a single case where people will spend more time overall because they spent it on building tools. I still have to find a case study like that after a decade of looking for it. So now in our case, Glamorous Toolkit itself is the first large case study of moldable development. And we are building, we just measured, for example, we saw that we sent over in our chat, we sent more than 3,700 pictures over the last year. So we sent more than this amount of pictures back and forth as an engineering tool between us over the last year. So that's more than 10 every single day. And that's on top of the videos and other things. And none of them, they are not funny pictures. They are engineering pictures. And they all show the inside of software systems. Now, in our case, we spent, let's say, you know, people will say, oh, well, that's ridiculous to spend so much time building tools, especially given that most of the tools we build, we actually throw away. We might even use a tool for 10 minutes and then throw it away afterwards. Because that's what happens, right? Like also, you know, like querying was similar, was kind of similar. Like it used to be that querying was carefully, there was a careful nomenclature of the queries over our system because it was so expensive to create those. But then once queries became so cheap to create that it didn't matter anymore, then people are just writing queries over queries as a matter of thinking. And that's basically what we are saying here, is that once you start thinking through tools and understand explicitly the need for these tools, you're going to be creating them because not doing it is just going to look like a waste.
Oh, no, by the way, I completely agree with you, right? And
I know, and I'm just saying, we're still to find out, right? We're still to find out. This is not a subject conversation yet. Not really. It should be a global subject conversation. We want it to be a global subject conversation. We have built Glamorous Toolkit, made it open source, exactly so that people can go and feel, right, and practice and go and apply it on their direct situations right now so that we can actually have that conversation, because I think it's essential to have it. And we will find out what the limit is. We didn't find it after a decade. Now, in practical terms, when we actually go, for example, let's say in a legacy system, and we get people are saying, okay, how do you steer agile architecture in some form, or you know, like maybe you want to split it into something, or maybe you want to ensure some bounding context, maybe you want to ensure certain performance characteristics, or whatever that is. We always add these. So software assessment implies two roles of moldable development. It implies two roles: the stakeholder and the facilitator. And the stakeholder is the one that is able to formulate the hypothesis and make a decision given an input. The facilitator is the one that is able to translate this hypothesis into some tools that provide some information that can be evaluated. So you can think of it, and these are they are support roles, right? So the facilitator is a support role, and then they reinforce each other. But the facilitator doesn't know how to do this. Now, we find that a good starting point is 1 to 8, 1 to 10. So one facilitator for a team of 10 people. That's a good starting point. It's definitely not a waste. In our case, for example, all of us in our team are also facilitators. We find that it's easier for a person to be a stakeholder at a time and have another one person to be a facilitator at the same time, even if we know how to handle it. It's just easier to pair like that. But interestingly enough, this is actually the cheapest thing to train, because you can train this. In our experience, it takes, for example, when it comes to Glamorous Toolkit, it takes about a month. So about a week to learn how to learn, because Glamorous Toolkit has tools. So it's built under the same principles. Like if you learn how to learn Glamorous Toolkit, you also learn how to use Glamorous Toolkit. It's a funny thing. But it takes about a week to get comfortable with those concepts in Glamorous Toolkit itself, and about a month to get proficient, or to start to exploit the tool for some direct value. But the most difficult thing to actually get is this one, the stakeholder. The stakeholder is more difficult, because that one you can't really train.
Well, I think there's, and it is interesting, because we're trying to solve this by selling our platform, or making the platform that we sell also a product, where the problem is a lot of the time the stakeholder. So what you're missing here is almost like the stakeholder has a set of business owners, right? Almost has a source of budget, right? Like who's funding whatever that is, because it doesn't matter. In a way, a lot of the times the cost of the tools are even not as significant as the cost of the people required to implement whatever that is, right? Or maintain it, right? I think the challenge sometimes is that the source of funding tends to come from specific features that are or actually specific visible things that. So if you go back to the other one, I think the other one is actually quite cool. So the one you were before, right? So if you go back to the one you just there, because I think the interesting element here, right? And this is where it also becomes a political and a business and economic model that you need to solve here, right? Which is, if the stakeholder is rewarded by delivering X features or X things, and the person that is buying that doesn't see how much effort, right, it took the stakeholder, and almost how efficient the stakeholder is, right? For all sorts of reasons, maybe he doesn't understand and have the time, whatever. It becomes very hard to start justifying facilitators, right? And I know that it makes sense once you've done this, because you buy the political fight to say, I'm going to do this regardless if the business asks me to. What I think is interesting is to create, or to start to show why developing without the facilitators is highly inefficient. Right? It's the same way of saying, if you develop, you don't have a good test suite. And by the way, a good test suite, actually using your language, is almost a facilitator, right? On when it goes well. If you cannot measure that inefficiency, it becomes also, again, harder to say, why should we be spending time on it, right? But I'm completely sold on this idea, because fundamentally, this is also how I like to develop and what I try to push to my teams. In fact, I have a member of my team that the whole team that we have is just operations. And their job is to be facilitators. Their job is to make the other teams more productive, right? The interesting element, which I would like, if you can go next now, is, so how do you integrate with existing IDEs, with existing development environments? I think you touched a little bit, and I think in one of your things you mentioned how you use it side by side. But if somebody's developing on VS Code or PyCharm or another tool, WebStorm, do you have good examples of areas where the Glamorous Toolkit adds a huge amount of value, right? Even if you don't write the code there, right? But as that, super REPL, right? That super feedback loop, that having access to that abstract syntax tree, for example, like I can see already that doing a security assessment, it's a massive toolkit, right? Because when you're doing, I now came from a generation that, we don't do black box testing, just, from the outside. You always want to do a gray box testing, which is you have access to the app and the source code. So you have a lot more context, right? So I could totally see how having access to the AST, and it does make me laugh, that thing, because I built stuff like that in the past, right? In fact, the thing I'm going to show on Friday on the O2 platform was actually a bit of a variation of this. I never took it to where you took it, but is that ability of building tools on tools on tools. So how can you show some good examples of like side-by-side integration where in a way you don't develop inside the Moldable development environment or the Glamorous Toolkit, you use it as a way to augment the existing workflows?
Yeah, so there are a couple of these scenarios. The first scenario is, so we look at complementary scenarios because indeed, while Glamorous Toolkit is a platform for constructing system-specific environments, so we think that, for example, the development experience of the future is not language-specific, but it's system-specific. So when you're going to look at a system, you should see on the screen that this is different than the other one. That you have, that your colleague that is working on some completely other system, right? Today, like if I stay 1 meter away from the screens, I have no chance of, they all look the same, right? The only thing is, do they use the light theme or the black theme? But that's not the difference that we're looking for. So while that's let's say the end goal, and that's what Glamorous Toolkit is, we do not want to, to tell people to switch altogether to a complete new environment, because that would not be feasible, and our goal is to educate. So what are the use cases? One use case is something we call like steering agile architecture as a domain, right? And like often when we are called, you raised an interesting point about the economics. So how do you justify? How do you teach people? How do you convince people of paying, right, or investing in this? Now, one thing to realize, and the reason I wanted to show you this one is because people have no problem already allocating, or the budget for reading. The budget is already allocated. So what we are saying is that if you can optimize just an individual's engineer's work, you actually don't even have to ask for the budget. That's our ambition. It should be so evident for engineers that they should be able to pick it up. So let's say that would be like the end goal. But then there are business cases where people do realize that, it doesn't matter how much the technical part costs because the other parts are more interesting. So let's say you're in a situation where you have a system and you can't compete on the market because you're not able to move the system quickly enough. So it's just, like the system is perfectly valid today, but you need to evolve it. So because, move from analog to digital with the COVID thing. And then all of a sudden you find yourself, I need to scale my system. But if I can't scale my system, then I'm losing business. And all of a sudden, all of those technical costs are completely irrelevant. What you care about is, can I actually move, right? And I don't care what I need to do to move, because that's the most important thing, is just to move. So that's one of those kinds of situations where people are immediately open to saying, how do I do that? Yeah, anything that would give me any promise to move in that direction, we can do this. So that's one of those places. And that's where this ability to reason about systems quickly is important. So this is one. The second one is for example, just coordinating the work with different APIs that people have. It's a simple thing. Yeah. So let's say people have all these logs, right? So let's say you're maybe during security, you'll have to go and coordinate, what happened on this log and versus that log and then that log. And if you think about, where the logs are and how people think about those, like people say, okay, this is the log from the client, this is the log on the server, this is the log for the errors, this is the log for some other things. And they're all in their own silos. And all of those silos usually are, guarded by a UI, right? A dedicated UI, which is really interesting for that specific silo. Is just completely not interesting for it's not interesting for the for you to be able to correlate. So how would you then be able to correlate? You would correlate it by bringing those APIs together, and you can coordinate that on the client side. So the Glamorous Toolkit is a tool for that. So you can create these kinds of little tools. I'll show an example of this. And the third reasonably interesting use case is that of something we call executable specifications or domain discovery. So working, people are saying, oh, let's do domain-driven design. And this all sounds great, right? And then people draw on a whiteboard. But how do you, how do you know that what's in the code is actually what's on the whiteboard? How do you know that the whiteboard is representative for what you have put in the code? And because people talk about the ubiquitous language, but as long as you do not see the ubiquitous language, right?
Well, you can't really talk about it. Code generated diagrams, right? You need, if anybody,
but about the domain.
Hope, yeah, like you said, somebody draws something like a hope, right? You hope that it actually looks like that, right? And that's one of the things when we do threat. Have you done threat modeling? Do you know about the threat modeling practice, right, in security?
Sure.
So threat modeling is a good practice where sometimes the value of it is just drawing architectures and having multiple people saying, well, that's not how it works, right? Okay, you might think it works like that, but actually, if you talk to enough people, you get a very good representation. I have tons of examples of finding massive security vulnerabilities on paper, right? Literally on a threat model, right? Because if you talk to enough people to understand how it works, right? Especially for access to code, you can go, well, that doesn't work like that, right? So I always felt that the solution here is to go from the bottom up, like you said. If somebody has to start doing a drawing, you're already lost because it means they don't understand how things go. You actually want drawings. You want pre-generated diagrams or diagrams that are generated from reality, from AWS developments, from CloudFormation deployments, Terraform scripts, right? From all the way to the code, right? Multiple levels of abstraction, right? That's what you want, right?
Yeah. So exactly, no, that's exactly it. So here's, like I mentioned, three things. I mentioned, how do you reason about architecture? This is one. And then also, once you reason about architecture, you want to be able to go and create constraints, for example. So architectural tests, for example, right? That encode all sorts of non-functional characteristics. So then you can think of Glamorous Toolkit as an IDE for exploring architecture and creating architecture constraints. So here's a typical, like this is the oldest exercise we have, and we have more than 1,000 people have followed this exercise, and we worked with them one-on-one. So it's the simplest evolutionary case that we could think of, and that's, imagine you have deprecated classes, or classes annotated with deprecated in Java, and now the reason you're annotated something with deprecated is because you want to remove them at some point. Now imagine that you're at some point, and now you want to go and evaluate which of those things that are annotated with deprecated you can remove, and of those that you cannot remove, what you need to do about that. So that's the exercise, right? Not doing it, just the evaluation of it. So the assessment part, and we're asking people, estimate how long. What kind of a time budget would you ask for your, PO, for example, during a sprint planning? What kind of a time budget would you ask for just to evaluate the problem, just to evaluate this problem? And then we tell them, well, imagine you already have a system like this. Oh, what happened here? Okay, just a second. So imagine you already have a system like this, and the system has what is that? It has 2,300, 2,500 classes, and in here there are 25 deprecated classes, right? That's the exercise. And so then we ask people to also speak out loud how they would go about finding these classes. So first of all, of course, you need to find the deprecated classes. And after you find the deprecated classes, you're gonna see which of them are still being used. And of those that are being used, you can remove, let's say, and those that you cannot, that are still being used, you need to go and investigate. So we are actually saying, so how do you do that? How do you evaluate these classes? So first is they're going to search for star deprecated star. And the thing about this is that if you're going to search for star deprecated star, in this case, you're going to get more than about almost 300 cases. And that's because star deprecated star will also give you attributes and methods that are deprecated. So not what you're looking for, which means that you will get, the reason this case study is interesting is because you get 90% of noise. But you only know that this is a noise at the end, right? When you're done here. So instead of doing that, we're saying, okay, let's do a query over classes and say, okay, give me all the classes that are entered with deprecated, just like that. So I get those 25. I can go and evaluate those. You can see, okay, this is the complete source code. This is the class entered by deprecated. This is the class entered by deprecated, and so on. So and then afterwards, right, when we say, well, how do you go about, imagine you have these 25 classes, how would you then know which of these you want to go and remove? And then we start counting the clicks, right, that people will make. And it immediately goes into maybe hundreds of clicks because people think in those kinds of terms. Now, instead of that, we can say, well, what if I'm going to search for it? So give me all those classes that are entered with deprecated and for which the clients we still have clients. So there are 11 of them, which means that if I'm going to search for those classes that are deprecated but do not have clients, it's 14 of them, I can just remove them right now. So if I have something like this, now I have 11. So what's interesting here is that like the question is, now I would need to spend some time to figure out which of these ones, what do I do about them? So one way would be I can write some more queries or maybe do some metrics or so. But another way to do it would be something like this. So here we're seeing a visualization of just the dependencies, just of these classes, plus the classes that are using them. So these are the deprecated classes. And these are the classes that are using the deprecated classes. And so here I can see, okay, look, there's a cluster here of 2 deprecated classes calling each other, so I don't really care. And this is probably going to be more expensive to reason about than these ones, one of these 2, right? Because in order for me to remove this one, I need to go and understand all these other places that are using it. While in order to remove one of these, I just need to go and understand this one. So from that perspective, right, it gives me an indication of about costs. Now, this still just gives us value. It gives us cost, but not necessarily value. So let's say that we already know something about this system, and we know that all the system has 2 components, the UI and the non-UI. So I'm going to just simply say I want a border here, and I'll color that border such that if the color, if the fully qualified name here includes the substring UI, that means like there is a package called UI somewhere in the path. If this is true, then I'll say I want to use a color blue. And if this is not true, I will be using if false, I will be using a color, I don't know, let's say I'll keep using gray. So if I now execute that, I see something like this. So now this is now contextual, right? So it's up to now, before I could apply the analysis to any Java system. This one only makes sense for this system because I have just taken into account, I mapped something that I know about the system. Now, of course, the question here is, which of these would we start from? Would we start from the UI or would we start from the model? That's the question for people. And then, of course, the answer is depends, because you have no way of knowing. There is no way of knowing from the outside what is good and what is value and what is not value until you're there in that context. So only people that are in the context, they can tell you, just like you were saying, that, just describe to me what is valuable, describe to me what your architecture is, and this is how we will figure things out. We can look at the technological parts, but we can never project value, or rarely.
Yeah.
So what you're seeing here, right? This is just something we created, and this takes is measured in about 10 minutes or so. Now, when we ask people to estimate before we do the exercise, we ask people to estimate how long they will ask for. They typically estimate 4 hours, and we've done it with more than 1,000 people.
Yeah.
So that's 4 hours is on the lower bound of the estimation side, right? So we're talking about an order of magnitude right here, right? And why is this interesting? Because this is the simplest possible evolutionary problem that we can think of. And you would expect, because this is like something you can find in textbooks, you would expect this to be super highly optimized, right? Because everybody knows about this problem. But if you can gain an order of magnitude difference on a very known problem, what do you do on the unknown problems, right? So that's just an idea.
The only other thing, so I'm actually, unfortunately, we do have to finish on the hour because there's another session that needs to use the same Zoom account, but we definitely continue on Friday, right?
We do.
So question for you, because basically, first of all, has anybody developed almost like a static analysis engine on top of this? Because basically what you have here is a really good...
Oh, there is a static analysis inside.
No, I'm saying from a point of view of, of actually, because what you're creating here is rules, right? In fact, what you've done was something I wish most of the static analysis engines, commercial ones, have done, was to make it almost a rules friendly, right? A very powerful rules creation engine, which is what you have here, right? You have the whole toolkit to create a rules. So once you arrive at a calculation, because you could evolve this and really determine, for example, a vulnerability, right? So if now, almost do Tenko analysis, saying, if you actually have a UI from here to a UI from there, that's a problem. Does anybody build actually an engine that then spits out and saying, for example, a vulnerability or an action or a task, right? Like take this to the next level.
Yeah, we go from here.
This.
Right. Yeah, we go from here. So we can take this one, and you can also directly integrate this one into continuous integration. Just from here, press a button and it's in your continuous integration, and that's your check. So will there be like packages of people providing prefabricated kinds of rules? I'm sure there will be, but I'm suggesting, just ask people, how many people are downloading unit tests from the web? Because that's the wrong model. It's just the wrong model. Nobody's downloading unit tests. People are writing unit tests. And it turns out it's not that difficult to write. Although people say, but this is so difficult to write. 20 years ago, people said this was very difficult to write. The only thing we need to do is just make the cost of writing much lower than people expect it to be. And then you will see how that skill emerges, because it's already present.
Yeah. So for Friday, can we try this? Can we try to write or show an example of how, for example, you write one of these, let's say to pick secrets, right? Let's say hard-coded secrets, right? On a code base. And then we actually try to run it, for example, on a GitHub Actions, right? Have you done something like that? Because that's integrated into a CI pipeline, right?
Well, yeah, for GitHub Actions, probably we'll need some, we don't have, that's not something we used in the cases where we worked with. We worked with Jenkins, for example, just deploy it like that. But there's nothing that would prevent us from running it somewhere.
Yeah, because that was kind of my final question was for today was, is literally that integration with the CI pipeline, right? Because I feel that, going to your process, right? I view that a lot of this is what you're packaging is basically is very specialized. What's it called? Knowledge, right? And then what we want is to basically capture that and package it in a way that it becomes very easy. It almost goes as a test, right? To make sure that, for example, when somebody does add something that they shouldn't be doing or some property, we capture it, right?
Yeah, so for example, yeah, indeed. And we even have, so here as an example of the other side. So, right, that's one use case. The other example, when it comes to the deployment pipeline, everybody goes to the, to a web, right? So it's definitely not expected to be integrated in the IDE. Here is a actual snippet that says, give me the Jenkins. This is our private Jenkins. And we're browsing it right there. And we say, okay, look, there was some failure over here. And let's say which node failed. This one failed. I can see something happen on Mac OS X and something happened on Windows. But actually, we have an architecture of this deployment pipeline. So it's not just a linear deployment, but it kind of looks like this and say, okay, look, this one actually failed here. So I can go there and I can see what failed. And I get here the steps in that pipeline node. And what I have here is actually syntax highlighting of the console, because we still are using this console. So we're having this one. Now, how do we create this? Because this is actually created specifically for our system. So if I look at the implementation of this console log, it's nothing but a text editor with a styler on it.
Yeah, and you're looking.
And so if I look at, and if I look now, and if I go into the styler and I want to see how the styler is implemented, I can see those rules. So now these rules are like little checks that are deployed into continuous integration so that we can find the error faster. Similarly, we can take architectural rules and deploy those into the pipeline as well. But again,
now this is and actually I really want to continue from here on Friday, because I think this is this goes to that moldable bit, right? So cool. Look, let's end on here today. This has been really good, and let's continue on Friday at 4 p.m. UK time. And really cool, man. All right, thanks for doing today's session.
Thank you. See you.
See ya. I'm gonna stop the recording.